The engineers at Nizhny Novgorod Radio Plant 154 had every reason to feel invincible in 1967. Their P-12 spoon rest radar represented 15 years of Soviet engineering excellence, a system so fundamental to Warsaw Pact air defense that factory production lines ran 24 hours daily, churning out units for deployment from East Germany to North Vietnam. The massive rectangular antenna, mounted on a rotating base that could scan a full 360 degrees in 12 seconds, could detect aircraft at ranges exceeding 275 kilometers. Head designer Yevgeny Berzin had personally supervised the integration of new klystron tubes that pushed output power to 600 kilowatts, enough to burn through most known jamming techniques. What made the P-12 particularly elegant was its simplicity. Unlike Western phased array systems that required teams of specialists and computer support, a single trained operator could run the entire station. The system operated on fixed frequencies between 147 and 161 megahertz, VHF band wavelengths that Soviet physicists knew were virtually immune to absorption by ground clutter or atmospheric interference. The massive dipole elements, each precisely cut to 1.9 meters, created such clean reflection patterns that operators could distinguish between a MiG-21 and a Mirage fighter at 150 kilometers based purely on radar cross-section signatures. By 1969, 72 P-12 units formed an overlapping defensive network across Egypt's Sinai Peninsula and along the Suez Canal. Soviet doctrine called this system Kruga Neprobivayamaya, the impenetrable ring. Egyptian operators trained for 6 months at facilities outside Sevastopol monitored their scopes with absolute confidence. The mathematics were irrefutable. Any aircraft attempting to penetrate Egyptian airspace would light up these screens like a bonfire. Detection was guaranteed. Interception was guaranteed. Israeli Air Force commanders would have to accept those facts or stay grounded. Colonel Dmitry Kvachkov, chief Soviet radar advisor stationed in Cairo, had personally walked Egyptian President Nasser through the system's capabilities during a November inspection. He demonstrated how the radar's frequency-hopping protocol cycled through 5 discrete channels every 2.3 seconds, making it essentially immune to interference. Even if the Israelis somehow developed jamming equipment for one frequency, the system would simply shift to another before they could adapt. The tall lattice towers supporting each P-12 antenna stood as visible monuments to Soviet technological supremacy, structures you could photograph from the air but could never defeat. The factory in Nizhny Novgorod received commendations from the Defense Ministry. Production bonuses were distributed. Berzin's team began preliminary designs for the P-15, which would extend detection ranges to 350 kilometers. The entire Soviet radar establishment operated under a single fundamental assumption. These systems were defensive installations. Heavy, permanent, dug into prepared positions with concrete foundations, supplied by dedicated power generators, protected by concentric rings of infantry and anti-aircraft batteries. You could bomb a P-12 site, certainly, but you'd lose aircraft doing it. You could maybe damage components with artillery if you fought your way close enough. But steal one? Physically remove a 7-ton radar system and its associated equipment from an active military base? The concept never appeared in threat assessments because it violated basic physics and logistics. The Israelis were capable adversaries, Kvachkov admitted, but they weren't magicians. The night shift operator at Ras Garib radar station checked his watch at 2147 hours on December 26, 1969. Lieutenant Ahmed Khalil had monitored this same screen for 11 months, watching the phosphorescent sweep paint Egyptian airspace in predictable patterns. Civilian traffic from Cairo showed as expected blips. His own patrol aircraft returned clear signatures. The system hummed with its characteristic 400 Hz tone that Soviet instructors said meant everything was functioning perfectly. Khalil poured another glass of tea. and settled in for another quiet night watching Israel's aircraft stay grounded on the far side of Sinai. At 2203 hours, his screen went white. Not dark, white. The entire cathode ray display washed out in blazing phosphorescence as if someone had pointed a searchlight directly into the antenna. Khalil's first thought was equipment failure. Maybe a klystron tube had spiked. He killed the transmitter, waited 30 seconds per Soviet protocol, restarted. The startup sequence looked normal. Magnetron warming, frequency selection cycling through channels 3, 1, 5, 2, 4 as programmed, power output reading nominal at 580 kilowatts. But the moment the antenna began rotating, the screen flooded white again. He grabbed the phone to the neighboring station at Ras Suder, 40 kilometers north. Their operator reported identical conditions. Dead white screens, no targets, no ground clutter, just burning phosphorescence that made radar operation impossible. Khalil ran outside to visually inspect the antenna. The massive rectangular array rotated smoothly on its mount. No visible damage, no smoke. The diesel generator rattled away normally. Everything looked exactly as it should. Back inside, he switched to backup frequency channels. White. He reduced power output to 400 kilowatts. White. He increased it to maximum 650 kilowatt emergency setting, knowing this could burn out components. Still white. Soviet technical manuals included troubleshooting procedures for 47 different malfunction scenarios. None of them produced this symptom. The radar wasn't broken. It was being drowned in electromagnetic noise on every frequency it could access. Then he heard them. Helicopter rotors. Multiple aircraft, low altitude, approaching from the Gulf of Suez. Khalil ran outside again and saw nothing. The moonless night and offshore approach gave him no visual confirmation. But the sound was unmistakable. Heavy transport helicopters, at least 4 of them, coming directly toward the coast. He sprinted back to the radar shelter and stared at his useless white screen. The aircraft producing those rotor sounds should have been painting massive returns at this range. Helicopters were radar reflective targets, almost impossible to miss. His screen showed absolutely nothing but white noise. At 22:47 hours, the jamming stopped as suddenly as it started. Khalil's screen cleared, showing normal ground return and atmospheric scatter. He immediately called the Regional Air Defense Coordinator in Cairo. "We experienced 44 minutes of complete radar blindness," he reported. "During that time, unidentified helicopters penetrated our coverage zone. We have no track data, no altitude information, no count of aircraft. They could have landed anywhere within 50 kilometers." The coordinator's response was sharp. "Are you reporting equipment malfunction?" "No, sir. The equipment functioned perfectly. We were jammed on all frequencies simultaneously." A long pause. "Lieutenant, the Israelis don't have that capability. The Americans don't have that capability. Check your systems again and file a written report in the morning." Khalil filed his report. Soviet advisors read it, noted the timestamp, and filed it in a growing folder labeled Unexplained Electronic Incidents. None of them connected it to the real operation that had just begun 90 kilometers south. Lieutenant Colonel Yevgeny Belov arrived at Ras Abu Darag radar station on December 29, 1969, carrying a Tektronix oscilloscope and a growing sense that the laws of physics were being rewritten without consulting Soviet engineers. The site sat empty, guard towers abandoned, equipment shelters vacant, perimeter fence cut in 3 places. Egyptian command had discovered the situation 12 hours earlier when a supply truck arrived to find the entire installation stripped clean. Not destroyed, not damaged by explosives, methodically disassembled and removed. Belov walked the compound with increasing disbelief. The P-12 radar had occupied a prepared concrete foundation, measuring 8 meters by 12 meters. Heavy anchor bolts, each 40 millimeters in diameter, protruded from the concrete where the antenna mount had been secured. Someone had removed the nuts carefully, using proper tools rather than cutting torches. The main equipment shelter still contained mounting racks, but every electronics cabinet was gone. Power cables had been cut, not ripped out, but severed with bolt cutters at precise intervals. Whoever did this understood the system architecture. He examined the cable cuts more closely. They were organized. Someone had separated cables by gauge and type. Main power lines cut at 1.5-meter lengths, coaxial RF feeds cut at the connector junction boxes, control wiring stripped from conduit in intact segments. This wasn't demolition. This was harvesting. Soviet doctrine assumed enemies would bomb radar sites or shell them with artillery. The idea that someone would steal the entire system, preserving its technical integrity, had never appeared in defensive planning. The perimeter showed similar precision. Fence cuts formed a straight path from the main road to the radar foundation, wide enough to drive a truck through, but no wider than necessary. Boot prints in the sand suggested at least 20 people, organized in teams. Some prints clustered around the antenna foundation, others near the equipment shelters. A third group concentrated at the power generator station. Belov found discarded Soviet-made cable ties that the Israelis had cut away during disassembly. They'd used the station's own supplies. He set up his oscilloscope at the neighboring Ras Suder station to analyze the jamming Khalil had reported. The interference pattern told a disturbing story. Standard jamming concentrated power across broad frequency ranges, creating a noise floor that degraded but didn't eliminate radar returns. The December 26th incident showed something different, precisely targeted barrage jamming that matched the P-12's specific operating frequencies with such accuracy that the receivers saturated completely. Someone had mapped the radar's frequency hopping sequence, all 5 channels in exact order with correct timing intervals. That knowledge could only come from 2 sources: captured technical manuals or access to an actual P-12 system for testing. Egyptian security protocols made manual theft nearly impossible. The manuals were classified documents stored in locked safes, with inventory checks every 72 hours, which meant the Israelis had somehow tested live P-12 systems before this operation. But how? Egyptian radars operated continuously under Soviet supervision. You couldn't just practice jamming them without someone noticing. Belov filed his report to Moscow on January 3, 1970. His conclusion was blunt. The adversary possesses complete technical knowledge of P-12 architecture, operating procedures, and electronic characteristics. They demonstrated capability to neutralize multiple installations simultaneously using coordinated jamming. They conducted ground operations with detailed understanding of system layout and disassembly procedures. Recommend immediate assumption that at least one complete P-12 system is now in enemy hands for analysis and exploitation. The response from Moscow arrived January 8th. Explain how the enemy acquired this knowledge. Your assessment implies unacceptable operational security failure. Major Yosef Argaman stood in a basement workshop at Ramat David Air Base in August 1969, staring at photographs that shouldn't exist. His intelligence team had spent 6 months bribing Egyptian maintenance workers, recruiting local fishermen as spotters, and flying high-altitude reconnaissance missions that pushed RF-4C Phantoms to 68,000 feet. The result was a portfolio documenting every P-12 radar station along the Gulf of Suez, guard rotation schedules, supply truck arrival times, even the names of individual Soviet advisors. But photographs weren't enough. Argaman needed the actual hardware. The problem was mass. A complete P-12 system weighed approximately 7 tons when you included the antenna array, rotating mount, electronics cabinets, and auxiliary power systems. Israeli transport helicopters, Sikorsky S-58s acquired from West Germany, had a maximum cargo capacity of 2,800 kilograms. The mathematics were unforgiving. You couldn't airlift a P-12 unless you separated components and made multiple trips, which extended ground time and multiplied risk factors. Argaman's operational window was 5 hours maximum. The interval between guard shift change at 2200 hours and the scheduled morning supply delivery at 0300 hours. He brought the problem to Captain David Ivry, an engineering officer who'd spent 2 years maintaining French radar systems before the 1967 arms embargo. Ivry examined the P-12 technical drawings that Mossad had acquired from a sympathetic Polish radar technician in 1968. "The antenna assembly is your real problem," Ivry explained, pointing to the massive dipole array. "It's 7.5 meters tall, built from aluminum tubing and steel reinforcement. Even if you unbolt it from the mount, you're looking at 1,200 kilograms that won't fit through a helicopter cargo door without cutting." Argaman authorized an experiment. Israeli engineers built a full-scale P-12 antenna mock-up at a secure facility in the Negev, using the exact dimensions from the stolen drawings. A team of 12 men, the maximum that could deploy on 3 helicopters, practiced disassembly procedures. First attempt took 9 hours. They refined the process, removing dipole elements first, disconnecting feed lines, unbolting the main frame in 3 sections. By the 40th practice run in early December, they'd reduced time to 4 hours and 18 minutes. The electronics cabinets presented different challenges. Each unit contained precision components that couldn't tolerate rough handling. Simply tipping a receiver cabinet beyond 30 degrees could shear vacuum tubes from their sockets or crack circuit boards. Ivry designed custom-padded crates with internal suspension systems sized to fit through helicopter doors. The crates added weight but protected components worth more than their mass in intelligence value. Argaman selected Ras Abu Darag for specific tactical reasons. The station sat isolated, 17 kilometers from the nearest Egyptian military installation. Geological surveys showed firm sand capable of supporting heavy helicopter landings, unlike the softer substrate at coastal sites. Most critically, the station's Soviet advisor, a Captain Mikhail Voronov, returned to Cairo every Friday evening to visit his Egyptian girlfriend, leaving only Egyptian personnel on site during weekends. The operation received formal authorization on December 15th. Argaman designated it Rooster 53, after the equipment designation in Soviet nomenclature. 4 transport helicopters would carry the extraction team. 8 F-4 Phantoms would create a diversion by striking Egyptian positions 30 kilometers north, pulling air defense attention away from the target zone. 6 additional aircraft would provide electronic jamming, using modified ALQ-87 pods that Israeli engineers had reprogrammed to match P-12 operating frequencies after months of signal intelligence collection. The final element was timing. December 27th was a Friday. Voronov would be in Cairo. Guard strength dropped to 12 men during weekend shifts. Moonrise occurred at 0347 hours, giving the team maximum darkness for approach and extraction. The Sikorsky S-58 crossed into Egyptian airspace at 2158 hours on December 27, 1969, flying 15 meters above the Gulf of Suez at 185 kilometers per hour. Captain Shimon Avner held the helicopter in tight formation with 3 other transports, navigation lights extinguished, relying entirely on terrain-following radar that showed the dark water as a flat green line on his scope. Behind him, 12 Commandos checked their weapons one final time. The lead engineer, Lieutenant Dov Sela, held a stopwatch synchronized to mission timeline. They had 4 hours and 42 minutes to complete what peacetime practice runs had accomplished in 4 hours 18 minutes. Touchdown at Ras Abu Darag came at 22:19 hours. Avner flared the helicopter onto hard-packed sand 80 meters from the radar installation, while the other 3 aircraft established a defensive perimeter. Commandos poured out, weapons ready, and secured the compound in 90 seconds. The 12 Egyptian guards caught during evening meal surrendered without firing a shot. They were flex-cuffed and placed in an equipment shelter under watch. No casualties, no shots fired, exactly as planned. Sellah's team hit the radar site running. First priority: disconnect all power systems to prevent accidental energization during disassembly. Chief Electrician Sergeant Avi Berman killed the main diesel generator, then methodically opened junction boxes to isolate individual circuits. He'd memorized the electrical layout from captured diagrams, 3 separate power feeds, color-coded in Soviet style with black for primary, red for backup, yellow for auxiliary systems. Each cable received a numbered tag before cutting. Someone in Tel Aviv would want to understand this wiring. The antenna team faced the most brutal physical labor. Staff Sergeant Yosef Klein coordinated 4 men attacking the D-pole array with socket wrenches and cutting tools. Each D-pole element connected to the main frame with 4 bolts, 16 bolts per element, 40 elements total. Klein's team had practiced until they could work by touch in darkness. They removed elements from top to bottom, passing each aluminum tube down in a careful chain, to avoid bending the precisely tuned metal. 38 minutes to strip the entire array. Meanwhile, Sellah supervised electronics removal. The main receiver cabinet weighed 380 kilograms and contained the system's most sensitive components. 4 men used a portable gantry, brought specifically for this purpose, to lift the cabinet clear of its mounting rails without tilting beyond the critical 30-degree angle. They lowered it into a padded crate, secured the suspension straps, and sealed the lid. 1 down, 5 cabinets to go. At 23:41 hours, the first helicopter lifted off carrying antenna components and 2 electronics crates. Maximum load, 2,650 kilograms. Ovner fought the controls as the overloaded S-58 clawed for altitude, turbine temperature redlining at 680 degrees Celsius. He gained 50 meters of altitude and turned west toward the Gulf, staying below Egyptian radar coverage. The second wave hit complications. The rotating mount, a massive steel assembly weighing 900 kilograms, had corroded onto its foundation bolts. Klein's team applied penetrating oil, waited precious minutes, then attacked the bolts with a portable hydraulic wrench. The first bolt sheared at 0:47 hours. They recalibrated torque settings and proceeded more carefully. 23 minutes lost to a problem they'd never encountered in practice. By 02:15 hours, 3 helicopter loads had departed. The site looked like an organized demolition. Cables coiled by type, mounting hardware sorted into bins. Even the concrete foundation swept clean of debris. Sellah's obsessive documentation meant every component could be reassembled in Tel Aviv exactly as the Soviets had configured it. The final helicopter, loaded with the rotating mount and remaining electronics, lifted off at 02:48 hours. 12 minutes inside the operational window. The Egyptian guards, released from the equipment shelter, watched the aircraft disappear into darkness. One of them found a note in Arabic. "Thank you for your cooperation. No one needs to die tonight." Colonel General Pavel Batitsky, commander of Soviet Air Defense Forces, arrived at the Ras Abu Darag site on January 4, 1970, with a team of forensic engineers from the Moscow Radio Technical Institute. He'd read Belov's preliminary report 3 times during the flight from Moscow, each reading deepening his conviction that this represented the most catastrophic intelligence breach in Soviet air defense history. Batitsky didn't care about the missing hardware. Factories could build replacement radars. He cared about what the Israelis now knew. His lead forensic analyst, Dr. Konstantin Ryazanov, spent 2 days examining the abandoned site with instruments that could detect microscopic evidence. What he found was worse than simple theft. The Israelis had left behind a detailed record of their technical sophistication. Every cable cut showed clean edges made with professional bolt cutters, sized correctly for cable gauge. Junction boxes had been opened with the proper tools, Soviet standard 19mm wrenches that suggested either captured equipment or precise intelligence on hardware specifications. Ryazanov discovered something particularly disturbing near the antenna foundation. The Israelis had left behind a small pile of discarded bolts, spares they'd brought in case factory-installed hardware was damaged or corroded. He examined them under magnification. They were exact Soviet specification. M16 grade 8.8 steel with 2.0 mm thread pitch and zinc phosphate coating matching Moscow production standards. Someone had manufactured these bolts specifically for this operation, which meant the Israelis possessed complete technical drawings showing every fastener type and size. The cable organization told an even darker story. Batitsky walked through the compound, noting how power cables had been cut at junction boxes rather than at arbitrary points. RF coaxial lines were severed at connector interfaces. Control wiring was removed in complete runs from transmitter to receiver. This wasn't salvage. This was documentation. The Israelis wanted to understand signal paths, voltage levels, and timing relationships. They'd taken the radar apart like engineers preparing a technical manual. Most damning were the missing logbooks. Soviet protocol required every P-12 installation to maintain detailed records, daily calibration measurements, frequency assignments, transmitter power outputs, maintenance schedules, and performance notes. The logbooks at Ras Abu Darag had been stored in a locked cabinet inside the operations shelter. That cabinet now stood empty, lock professionally picked. The Israelis had taken operational data spanning 11 months, every frequency the radar had used, every target it had tracked, every jamming incident it had encountered. Batitsky convened his engineering team in Cairo on January 7th. Assume the adversary now possesses complete knowledge of P-12 characteristics, he told them. Assume they can replicate our frequency-hopping sequences. Assume they understand signal processing, antenna patterns, and receiver sensitivity. He paused, letting the implications settle. Now tell me how to defend against an enemy who knows our systems as well as we do. The engineers had no good answers. You could change operating frequencies, but the P-12's hardware limited you to the VHF band between 147 and 161 megahertz. You could modify the frequency hopping sequence, but the basic timing was constrained by klystron warm-up cycles and mechanical antenna rotation. You could increase transmitter power, but that just made the radar more visible to direction-finding equipment. Every proposed countermeasure ran into fundamental design limitations. Dr. Ryazanov delivered the formal assessment on January 15. The P-12 system must be considered compromised. All units operating in combat zones should be assumed vulnerable to precisely targeted electronic countermeasures. Recommend immediate development of replacement systems using entirely new operating principles. Moscow approved the recommendation, but developing new radar systems would take years. The P-12 units already deployed, hundreds of them across the Middle East, Eastern Europe, and Southeast Asia, would remain in service, vulnerable, their secrets exposed. The disassembled P-12 arrived at Ramat David Air Base on December 28, 1969, where Israeli engineers had prepared a classified workshop with the urgency of men who knew they held a ticking clock. Lieutenant Colonel Amos Horev, Chief of Israeli Air Force Technical Intelligence, gave his team 72 hours to complete initial analysis before American observers arrived. The agreement with Washington was explicit. Israel could keep the radar for detailed long-term study, but the United States got complete access to findings within 1 week in exchange for accelerated delivery of F-4 Phantom fighters. Horev's engineers worked in shifts, photographing every component before reassembly. They discovered immediately why Soviet designers had such confidence in the system. The receiver front end used a superheterodyne design with 7 stages of amplification, providing sensitivity capable of detecting targets with radar cross-sections as small as 2 square meters at a 150-kilometer range. The frequency synthesizer was elegant, a crystal-controlled system that could hop between 5 preset channels with switching time under 100 milliseconds. Soviet engineering wasn't crude. It was robust, reliable, and extremely competent within its design parameters. But competence created exploitable patterns. Dr. Yehuda Katz, an electrical engineer who'd studied Soviet design philosophy during his doctorate at MIT, identified the critical vulnerability within 18 hours of examination. The P-12's receiver used automatic gain control to prevent overload from strong signals. When the radar detected a powerful return, like an approaching aircraft, it reduced amplification to keep the display readable, standard practice in every radar system ever built. Katz discovered that the AGC circuit responded to total received power, not to specific target signatures. Feed the receiver enough raw RF energy on its operating frequency, and the AGC would reduce gain so aggressively that real targets disappeared into the noise floor. Soviet designers had installed filtering to reject signals outside the radar's operating band, but those filters couldn't distinguish between legitimate returns and hostile jamming if both arrived on the same frequency. The P-12's frequency hopping was meant to solve this problem by jumping away from jamming. But if you knew all 5 frequencies and could jam them simultaneously, the radar had nowhere to hide. The American delegation arrived on January 3, 1970. Colonel Richard Evans from the Air Force's Rome Air Development Center brought a team of 6 specialists who spent 4 days examining the captured system. What excited them most wasn't the radar itself, but the integrated network architecture that Soviet logbooks revealed. The P-12 units didn't operate independently. They fed data to central coordination posts that fused information from multiple radars to create comprehensive air defense coverage. Evans immediately recognized the implications. "You compromise one radar. You don't just blind that sector," he explained to Horev. "You inject false targets into the entire network. Make one P-12 see phantoms, and the coordination post redirects fighters and missiles toward ghosts, while real aircraft slip through unmolested." Soviet doctrine's greatest strength, integration and redundancy, became a vulnerability when the enemy understood the network's language. The technical data transfer happened January 8 in a secure conference room. Israeli engineers presented complete frequency lists, timing diagrams, receiver sensitivity curves, antenna radiation patterns, and AGC response characteristics. American analysts took notes on every detail. Within 3 weeks, engineers at Raytheon and General Electric began developing the ALQ-119 electronic countermeasures pod, designed specifically to exploit P-12 vulnerabilities. The pod could broadcast jamming on all 5 P-12 frequencies simultaneously, while cycling through sophisticated deception modes that triggered false tracks on Soviet displays. The stolen radar gave American and Israeli forces a complete blueprint of Soviet air defense doctrine. Every P-12 variant, and there were dozens deployed worldwide, shared the same fundamental design. One captured system compromised them all. The first operational test of captured P-12 intelligence came on April 18, 1970, during an Israeli airstrike against Egyptian positions at Ras Banas. 4 F-4 Phantoms approached the target area equipped with modified ALQ-87 jamming pods, reprogrammed with the exact frequencies and timing sequences Israeli engineers had extracted from the stolen radar. Egyptian operators watched their screens dissolve into chaos. False targets multiplied across their displays, showing impossible flight paths that violated basic physics. Real aircraft appeared as ghost returns that faded in and out of detection. The Phantoms delivered their ordnance and departed while Egyptian interceptors chased Phantoms over the Red Sea. But the true vindication came 12 years later in Lebanon's Bekaa Valley, where the technology gap that began with Operation Rooster 53 reached its inevitable conclusion. Syrian forces had deployed one of the most sophisticated air defense networks ever assembled. 19 SA-6 missile batteries, multiple SA-8 mobile units, and a layered radar network anchored by updated Soviet systems that traced their design lineage directly to the P-12. Syrian commanders, trained by Soviet advisors who remembered the 1969 theft, believed they'd corrected the vulnerabilities. New radars operated on different frequencies. Improved signal processing filtered jamming. Redundant networks provided overlapping coverage. They were wrong. American engineers had spent 12 years refining electronic warfare techniques based on the captured Egyptian radar. The ALQ-119 pod evolved into the ALQ-131, which incorporated not just jamming, but active deception. Israeli engineers added their own innovations, developing the capability to capture, analyze, and retransmit modified radar signals in real time. By June 1982, Israeli F-15s and F-16s carried ECM suites that could fingerprint Soviet radar emissions, identify the specific model and configuration, and deploy precisely tailored countermeasures within milliseconds. The air battle over Bekaa Valley on June 9, 1982, lasted approximately 2 hours. Israeli aircraft, guided by E-2C Hawkeye early warning planes and supported by ground-launched drones that baited Syrian missiles into revealing their positions, methodically dismantled the air defense network. Syrian radar operators reported massive jamming that whited out their screens, the same symptom Egyptian operators had described in 1969. Syrian interceptors, launched without effective radar guidance, found themselves engaged by Israeli fighters who had complete situational awareness while Syrian pilots flew essentially blind. The statistics were devastating. Syria lost 82 aircraft, MiG-21s, MiG-23s, and Su-22s. Israel lost 0. Not a single Israeli aircraft fell to Syrian action during those 2 hours. American military analysts called it the most lopsided air combat result in modern warfare history. Soviet advisors filed classified reports acknowledging that their entire air defense doctrine had been compromised. The technological advantage traced directly to December 27, 1969. Every innovation in Israeli and American electronic warfare during those 12 years built on knowledge extracted from that single captured P-12 radar. Engineers knew the exact receiver characteristics, the precise AGC response curves, the specific frequency hopping algorithms. They understood how Soviet radars processed signals, how operators interpreted displays, how network coordination worked. That knowledge let them develop countermeasures that didn't just degrade Soviet radar performance. They made Soviet radars worse than useless, turning them into sources of false information that degraded overall defensive effectiveness. The Bekaa Valley massacre validated Yosef Argamon's obsession with capturing intact hardware, rather than just photographing installations. Technical drawings showed you what components looked like. Captured equipment showed you how they actually behaved under stress, where the design compromises were, which theoretical capabilities translated to real-world vulnerabilities. 5 hours of precise theft in the Egyptian desert had purchased 12 years of technological superiority that culminated in the most one-sided air battle of the Cold War. The P-12 spoon rest never recovered from December 27, 1969. Soviet engineers spent the next decade attempting to patch vulnerabilities in a system whose fundamental architecture had been completely exposed. They developed the P-18 spoon rest D with improved frequency agility, the P-19 with better signal processing, and eventually the P-35 and P-37 with entirely new operating principles. But every modification faced the same insurmountable problem. Israeli and American engineers possessed complete knowledge of Soviet radar design philosophy, operational doctrine, and integration methodology. The intelligence windfall extended beyond technical specifications. Captured maintenance logs revealed Soviet reliability problems, which components failed most frequently, which environmental conditions degraded performance, how long systems could operate before requiring recalibration. Israeli targeters used this information to time strikes for maximum effectiveness, hitting radar sites during known maintenance windows or after desert sandstorms that Soviet manuals indicated would degrade performance for 72 hours. Training documents found in the Ras Abu Darag operations shelter proved equally valuable. They showed how Soviet instructors taught Egyptian operators to interpret displays, which tracks to prioritize, how to coordinate with adjacent radar sites. American intelligence agencies studied these materials to understand decision-making processes. When developing tactics for Wild Weasel anti-radar missions, American planners knew exactly how Soviet-trained operators would respond to specific jamming patterns because they'd read the training manuals that shaped those responses. The strategic implications rippled through Cold War military planning. NATO air forces, previously concerned about penetrating Soviet air defense networks in any hypothetical European conflict, gained confidence that electronic warfare could neutralize radar systems long enough for strike packages to reach targets. The Soviet Union, aware that their radar technology had been comprehensively compromised, invested billions of rubles in crash programs to develop replacement systems. Those resources came from other military programs: ship construction, tank production, strategic missile development. Perhaps most significantly, the theft demonstrated that sophisticated military technology could be defeated through intelligence operations rather than direct combat. You didn't need to destroy every radar site with expensive missiles and inevitable aircraft losses. You could steal one system, analyze it completely, develop countermeasures, and neutralize hundreds of identical installations without firing a shot. This philosophy influenced American military doctrine for decades, emphasizing signals intelligence and electronic warfare as alternatives to kinetic operations. The human cost was measured in careers. Colonel General Batitsky faced intense criticism for failing to anticipate the vulnerability. He argued correctly that defensive doctrine had never considered the theft scenario because it violated assumptions about how wars were fought. His critics in Moscow countered that assumptions were luxuries Soviet forces couldn't afford when facing adversaries as innovative as Israel. Batitsky retained his command, but the incident marked his advancement ceiling. Soviet radar designers at Nizhny Novgorod Radio Plant 154 found themselves subjected to security reviews and polygraph examinations, suspected of being the source of leaked technical drawings that had enabled such precise disassembly. For Yosef Argaman, December 27th represented vindication of an obsession that colleagues had considered reckless. He'd risked 4 helicopters, 12 commandos, and international condemnation to capture a radar that could have been photographed or bombed. The operation succeeded because he understood a principle that Soviet planners had missed. In technological warfare, the enemy you understand is the enemy you defeat. The Soviets built excellent radars. They deployed them competently. They trained operators thoroughly. None of it mattered once their adversary possessed complete knowledge of how those systems actually worked. 1 radar, 5 hours, 12 years of air superiority. The mathematics of intelligence operations don't follow normal calculus.